Hello Year 8 and welcome to another maths lesson. As you can see, my classroom's still in a decent state, although we seem to have an intruder somewhere in the room. I wonder if you can spot him. Right, okay. Today's lesson, Statistics 8. Can you compare sets of data using various averages? Success criteria, bronze knows how to find range, mean, mode and median. Silver can compare sets of data using various averages. Gold understands the importance of using different averages to compare sets of data. Now, as usual, we start with a do now, fast 5 questions. If you would like to pause your video and unpause it when you've had a go at those 5 questions, please. Okay, let's see how you've done with these. Question 1, the mode, the most common number. 2, the range, the difference between the highest and lowest value, 27 take away 1 is 26. The median, the middle value when the putting order of size, 4. How many quarters make 3 full ones? Think of 3 pizzas split into 4 each. 3 fours, 12. And question 5 might look awkward, but it's just the same as question 4. 3 divided by a quarter, how many quarters in 3? 12. Right, I forgot to mention our keywords for today are data, mean, mode, range, median, compare, value and set. Let's move on. Right, so we're starting to look at the range, but before we begin, let's make sure that you've all got pen and paper ready and a calculator, because you will need that today again. If you want to pause until you've got this, or if you're ready to continue, let's continue now. Jelly beans. What is the range of these estimates? Calculate the mean of these estimates. Just one moment. Excuse me, Year 8. Right, this is some raw data that's been collected by a group of 8 girls looking at this picture of jelly beans in the top right. They've estimated the number of beans, jelly beans, that's in this picture. For this set of data values, you've got to work out the range of the estimates, you've got to work out the mean for these estimates. Now, under the picture, in a group of 8 boys, the range of their estimates is 240 and the mean of their estimates is 250. So here we don't have raw data, here we have statistical data. We have data about the range and about the mean for a group of 8 boys. The question is to compare and comment on the estimates made by the boys and the girls. Now we can't compare statistical data with raw data, which is why the first thing you have to do is work out the range and the mean for the girls. So pause your video, people, have a go at this and unpause it when you've worked out the answers and made some comparisons and comments on the estimates. Okay, let's have a look. First of all, the range for the girls is 130 take away 70, which is 60. The mean for the estimates, we add up all the girls' estimates and divide by 8 because there are 8 girls. The mean is 96.9. Now, the boys, their range was 240, their mean was 250. The girls were more consistent. Now, what we mean by consistent is that their range was much smaller. Their range was between 70 and 130, so it was fairly consistent, whereas the boys had a range of 240. That means if the lowest boy had estimated 70, the highest boy would have estimated 240 more than that, which is 310. Massive difference there, massive difference. So the girls were more consistent. The girls also had a lower mean. Their mean estimate was just under 97. The boys' estimate was 250. Their mean estimate was 250. So this would be a decent comparison of their range and their mean. Moving on. So, in your own words, how do you calculate the range of a group of numbers? Pause your video, please, people, and write down in your own words what we mean by the range. Okay, let's see. The range is the largest data value less the smallest data value. That's perhaps the simplest way of remembering it. You take the biggest number, the smallest number, and subtract the smallest from the largest. Another way of thinking of it, it's just the difference between the largest and smallest data value. Take the biggest, take the smallest, the difference between them. Moving on. So, comparing. Here we have two different football teams. In yellow, the goals scored in matches by some Premier League football teams. There we have them. In blue, some goals scored in matches by some Championship League teams. Now, for yellow, what is the range and mean number of goals scored? And then under the blue team scores, it says compare the number of goals scored by these Premier and Championship League football teams. Now, it does not say in the blue box, it does not say what is the range and mean number of goals scored. However, if you are going to compare the number of goals scored, then you need to compare statistical data. You do not compare raw data. For instance, you would not say in the first game, this team scored 3, this team scored 1. That is not a comparison. That has no value mathematically or statistically at all. You need to compare range and mean. So you will need to work out the range and the mean for these teams. You'll need to work out the range and the mean for these teams and then make your comparisons afterwards. So pause the video, answer the questions, and then unpause the video when you are ready to mark your answers. Okay, let's see. So, in the yellow box, the Premier League teams, their range was 5, which was 5 take away 0. Their mean was 1.8. Add them all up and divide by how many games they played. In the blue box, for the Championship League, their range was 6 and their mean was 2.7. So, the Championship team is less consistent. They're less consistent because their range was higher than the range of Premier League football teams. Only slightly higher, but it's still enough to say that their scoring is less consistent. But the important thing, they have a greater mean score. Their average score, their mean score during a game is 2.7 goals, whereas the mean score of the Premier League teams was only 1.8 goals. This is what we mean by a comparison. That is what we need to see. Moving on. Using the range again. Mark and Ken keep a record of their run score in 10 cricket matches. Basically, for anybody who doesn't play cricket, you hit the ball and you can score runs. And those runs mount up over the course of a game. You can score 0, which is where you are bowled out very, very quickly without scoring any runs. You can score 104. If you score 100, it's called a century, which is a very good score for a game. Now, these are the scores that Mark and Ken got over 10 different matches. What you've got to do is work out who you think is the better batsman and why. By now, hopefully you've realised that you are not just comparing each individual game. For instance, if you were, you could say, oh, Ken's better, Ken's better, Ken's better. Oh, Mark's better, Mark's better, Ken's better, Mark's better. No, that does no good whatsoever. We've got to use the range and the mean, the tools at our command, in order to interpret the data. So, pause the video, have a go at this, and unpause the video when you are ready to assess your answers. Okay, let's have a look. So for Mark, the range of Mark's score was actually, slight error there, the range of Mark's score was actually 104, which is 104 take away 0. His mean, when we add all those scores together and divide by 10, is 34.5. That means that on average he scored 34.5 runs per match. Ken his range was 24 and his mean was 31.3. So what we can say is, although Mark has a higher mean, he is far more inconsistent than Ken. Mark's range is 104 runs. In other words, the captain of his cricket team doesn't know when he sends him out to play whether he's going to get a fantastic score, like 104 or 81, or whether he's going to get an awful score, like 0 or 2. He's a very inconsistent player. Ken has a much lower range. Therefore, Ken is a far more consistent player. He may only score 20s, 30s or 40s, but when you send Ken out to bat, you know the type of score that Ken is likely to get. His mean is 31.3, so he's likely to get a score around the 30 mark. He'll get a few that are below and a few that are higher, but in general, Ken is more reliable. Mark is pretty much an unknown quantity. You could send him out tomorrow and he could score 80 or 90. You could send him out tomorrow and he could come back having scored nothing. So of the two, I would say Ken is the better batsman. Right, another typical type of question, typical statistical problem. A journey to work. Victor can travel to work on the bus or on the train. He uses each method 20 times and records the length of his journey. So here's how long it takes him on the bus, here's how long it takes him on the train. How could you compare the two data sets? I want you to think about. Victor has a very important meeting at 9 AM on Tuesday. He catches transport at 8:10 AM. His work is 3 minutes from the bus and the train station. Should he take the bus or the train to work, and why? Okay, so quite a lot to think about there. And this is one of the reasons that you would use data. We've got evidence here, evidence-based data. He wouldn't just go out in the morning and say, oh, I'm going to catch the bus or I'm going to catch the train. He can look at this data now and have hard facts, hard statistical evidence in front of him to decide which of them is most likely to get him to where he needs to be on time. So, using the data techniques that you've got so far, I want you to pause the video and have a go at answering these questions. Okay, let's see how you've done. Well, for the bus, the range is 21 minutes. In other words, the difference between the longest journey and the shortest journey is 21 minutes. And the mean time is 44.55 minutes. Whereas on the train, the range is 11 minutes and the mean time is 44.35 minutes. So in other words, the means are very similar, just under 3/4 of an hour, just under 45 minutes. But the bus is less consistent than the train. In other words, if he took the bus, it could take him up to 21 minutes longer some days than it does other days. Whereas with the train, there is only a range of 11 minutes. If you look at the raw data for trains, it's nearly always in the 40s. There's one that goes up to 50, there's one that goes down to 39, but the train is more consistent, the train is more reliable. Therefore, Victor should take the train. Mean time's 45 minutes. Add the 3 minutes, that's 48 minutes. He's got 50 minutes to get there. This has only ever taken 50 minutes once. He should be okay. He should be all right to get there if he takes the train. So now we move on to looking at how we can use the median and the mode. Jelly beans again. What is the class estimate and how could you find out? Well, before we actually approach the question, let's look at 3 people arguing about it. I will calculate the mean to tell us the average. No, no, no. The mode is the best average. Oh, but there's some extreme values there. I would find the median value. Well, who is right? We could certainly work out the mean, we could certainly work out the mode, and we could certainly work out the median. First off, let's make sure that you can remember what we mean by the median and the mode. So I'd like you to write down in your own words your definitions, please, for the median of a set of numbers and the mode for a set of numbers. Pause your video and unpause it when you are ready to continue. Okay. The median is the middle data value when all the values are put in order, and the mode is the data value which appears most often. Now, just as a little extra to that, the mode doesn't always have to be a number. As we've mentioned in a previous lesson, the mode can actually be an object. For instance, if we were collecting data on favourite TV shows and Coronation Street turned out to be the most popular TV show, then the mode would be Coronation Street. So back to this question, jelly beans. There we have a selection of estimates, quite wild estimates for that little diagram, but let's assume it's a three-dimensional image and there's a lot more jelly beans up there than you can perhaps see. So there's our estimate. What's the class estimate? How could you find out? I want you to pause the video, thinking about median, thinking about mode, thinking about the questions, see what you can come up with. Pause the video and unpause it when you've got an answer. Okay, let's have a look. Right, up here I've just put the data, the raw data, into order from smallest to highest, just to help me in a couple of moments time. First off, 100 appears 3 times, no other value does, so the mode is 100. Okay, the most frequent answer given by the class members was 100. The median, the middle value when the numbers are put in order of size, is 111. That's the median. The range, highest data value, take away the lowest data value, 923, take away 100, the range is 823, and the mean, all those data values add up to 2,345, we divide that by 9, we get 260.6. Now I've put the median as being the best average for this, for the best class estimate. Why have I put median? Well, let's just have a look at why I've excluded the others. The mean, 260.6. The mean has been greatly exaggerated by this 923 and this 550. They've made the mean much more significant, much higher than it actually is. If we look at the data values in order of size, there's only 2 data values higher than 200. So for the mean to be 260, it's been skewed because of these higher data values. Similarly, the range, 823, because of this one-off extreme value over here, this outlier, the range is not an appropriate number to use for the class estimate. The mode isn't too bad. These 3 numbers all down here, all being 100, wouldn't be too bad an answer. However, if we had another 923 on the end instead of a 550, and 1 or 2 of these had been slightly different, 101, 102, then 923 could have been the mode, and that would have been absolutely useless. So the mode really doesn't help us in this instance. The median, the number bang in the middle, is our best class estimate for this particular set of data values, for this particular set. Right, now here you've got a choice of mean, mode and median, 4 different things: most popular chocolate bar, the typical height of a student in your class, the average age of members of a health club, and the average salary of an employee at your school. Okay, let's pause the video have a go at saying which average you think would be best for each of these types of data. Okay, let's see. Most popular chocolate bar, that's non-numeric. It has to be the mode. The typical height of a student in your class. Imagine everybody in the class all standing against the whiteboard, from the smallest to the tallest. We want the typical height of a student in the class. So in other words, we want to ignore the extremes. We might have somebody incredibly short or somebody incredibly tall. We want to ignore those, so we will go for the person in the middle, the median, as being typical. The average age of members of a health club. Well, here we want to include everybody, so we would take the mean. The average salary of an employee at your school. Well, in a school, you have people who work full-time, who work part-time, and some people who perhaps, like examination invigilators, who might only come in for a couple of hours a day, maybe 2 or 3 weeks a year, and therefore, although they are employees of the school, they will only earn a very small amount compared to somebody who is a full-time teacher who's there 52 weeks of the year. So again, we've got to get rid of the extremes, people who perhaps earn a very small amount from the set of data. And therefore, once again, for the average salary of an employee, the median value would be the best average to take. Moving on. Which averages are possible, but even more so, which is the most sensible average again to use for these 3 examples? And I would like you to pause the video, have a think about these 3 examples and decide which average, mode, median, range or mean would be most appropriate for these 3 examples. Pause your video and unpause it when you are ready to continue. Okay, let's continue. So for the first one, we are looking at listening to music, reading a paper or reading a book. Since these are non-numerical data, we have to have the mode, and since most people are listening to music, the mode would be listening to music. The second one, 20 people run up a flight of stairs. Their times in seconds are recorded. 5, 6, 8, oh dear. There's me taking 200 seconds. This is an outlier. That would affect the range and the mean. The mode here would be pointless. We've got 4 people taking 15 seconds, but it doesn't really tell us anything about this data. So the median value, the one bang in the middle somewhere here, would be the most sensible average to take, because it gets rid of the extremes. Here are some percentage scores of students' test results. Again, here the median would be most appropriate. It ignores these outliers at the start, the 5 and the 6, and it gives a very good idea of where the average is for the group. There's no mode, all individual values here. And the range and mean would both be skewed by the 5 and 6 at the start. So they're not worth bothering with. Median only. Moving on. Right, making changes. A couple of problems here for you to think about. First one, what measures, which averages will stay the same if I change the number 68 in this set of data up to 88? Pause the video and decide for yourselves whether it will change mean, mode, median and range. And pause the video when you are ready to mark your answers. Okay, let's have a look. Right, mode. If I change that to 88, there's no mode at all. So that doesn't change. Median. Well, if I change that to 88, the median is still between 36 and 56. So the median stays the same at 46. If I change 68 to 88, the range is going to change. And the mean, I'm making this number bigger, so the mean, the total is going to be bigger, the mean is going to be bigger. The mean changes. Okay, Let's see if you can remember a little bit about the median. If there's 7 numbers, the median will be the 4th value, one at the start, one at the end, start, end until you're left with 1 in the middle. So with 7 numbers, the median is the 4th value. Similarly, if there were 17 numbers, the median will be the 9th value. If there are 27 numbers, where will the median be? Let's have a think about that for a minute. 7 numbers, the median is the 4th. 17 numbers, the median is the 9th. What's the relationship between 7 and 4, 17 and 9? How will I get the median? Where will the median be if there are 27 numbers? Well, if you can remember, we had 27, you add 1 to it, and then we divide by 2. 27 add 1 is 28, divided by 2 equals the 14th. The 14th value. The median will be the 14th value. So what if I have n numbers? And this is the formula that we met before. Can you remember that formula? Pause the video. It should only take you a few seconds to write that formula down. Unpause the video when you're ready to check. Okay. The formula, number of values add 1 divided by 2. And if we just look back here, that's exactly what I did down here. Number of values 27, add 1 and divide by 2. Here 7 add 1 is 8, divided by 2 is 4. 17 add 1 is 18, divided by 2 is 9. So n add 1 divided by 2 gives you the median value. But what happens when we've got an even number of data values? I've got 6 values. How do I find the median now? Pause the video and see if you can find the median for these 6 data values. Okay, let's have a look and see what you've done. Well, when you've got an even number of data values, what you have to do is you have to look at the middle 2 data values, which here are 3.3 and 6.2, add them together, gives you 9.5, and then divide that by 2 to get the median. 9.5 divided by 2 is 4.75. The median is 4.75, even though that number doesn't appear in the list. In fact, 4.75 is exactly halfway between 3.3 and 6.2. So we add the middle 2 values and divide whatever that is by 2. What's gone wrong here? Quite a simple question. This guy thinks 7.2 is a middle number, so the median is 7.2. Why is this guy wrong? Have a think about it, jot it down if you want to, pause the video, unpause the video when you're ready to check. Okay. You've got to put the numbers in increasing order first. Okay, quite a few people mess up on these median questions. They just go for the number bang in the middle. They forget to put them in order of size first. Don't be one of those. And our final challenging question for today's lesson in terms of P. So we've got 1, 2, 3, 4, 5, 6 numbers there. Arrange the numbers in ascending order. And then you've got to find the median of the numbers in terms of P. Find the value of P if the median of the numbers is 20, and calculate the mean of the numbers. It's quite a tricky little question, this. It's a lovely question as far as I'm concerned. I would like you to pause your video, have a proper good go at this question, because I like it, and then when you've had a go, pause, unpause your video, and let's see how you've done. Okay, let's see how you've done. So, numbers in order. Well, they all start with P, so we can forget about that when we're putting them in order. And then it's negative 15, negative 9, negative 3, plus 5, plus 6, plus 10. So P minus 15, P minus 9, P minus 3, P add 5, P add 6, P add 10. There we are, the rolling order. Find the median of the numbers in terms of P. So the median, as we've seen on the previous slide, we add the middle two numbers, p minus 3, add p, add 5, and we divide that by 2. Well, p add p is 2p, negative 3 add 5 is plus 2. So we have 2p add 2, all divided by 2, which ends up giving us p plus 1. So the median is p plus 1. Find the value of p if the median of the numbers is 20. So we're told that p plus 1 equals 20. And if that's the case, p must equal 19. So now, if we know that p is 19, we can replace all of these by changing p into 19. So the first one is 19 take away 15, which is 4. 19 take away 9, which is 10. 19 take away 3, which is 16. 19 add 5, which is 24. 19 add 6, which is 25. 19 add 10. Why on earth? 19 add 10, I've made a mistake here. 19 add 10, which is 29. And that lot adds up to 108. And 108 divided by 6 is 18. So our mean is 18. Right, sorry about having to correct that just there. I'll just very quickly run through that again. These numbers are found by substituting p equals 19 into each of these expressions. 19 take away 15, 19 take away 9, 19 take away 3, 19 add 5, 19 add 6, and 19 add 10. Add all those together, we get 108. Divide it by 6, because there are 6 numbers, and that equals 18. So our mean is 18. And that, year 8, brings us to the end of Statistics Lesson 8. Quite a lengthy lesson, I know, but hopefully now you've seen how we can use our averages in real-life situations in order to solve problems. Statistics, quite honestly, is absolutely massive in the real world. And if you have a good understanding of statistics and the use of statistics, it opens up so many opportunities in the world. So many different careers use statistics. And if you can interpret statistics properly, then you can have a fantastic future. Anyway, I'll leave it at that and let you get back to enjoying your day. Thank you and goodbye.